In this video, we are going to look at Unit 7, Lesson 5, which is triangles and circles, and we're going to see how perpendicular bisectors relate to circumscribed circles. So in this lesson, by the end of the lesson, you are going to be able to take 3 towns and be able to construct where a school should be placed that will be the same distance from each of the 3 towns. So starting on page 173, we're going to construct the perpendicular bisector of segment AB. So if you remember how to do that, take your compass. You will set it on either point A or point B. Then you can open it all the way to B if you would like. It just has to stay at least halfway. Well, not at least halfway, more than halfway, so that your circles will intersect. So if you'd like, you can just open it all the way and then draw in a circle. Keep your compass setting the same. Set your compass on B and then draw a circle again. And then connect these 2 intersection points, and that will give you your perpendicular bisector. So go ahead and make sure that you have done that. So construct the perpendicular bisector of AB. Then what you're going to do is you're going to take that perpendicular bisector that you just created, and you're going to draw a point D anywhere on the perpendicular bisector. So it doesn't matter where it is, just anywhere on the perpendicular bisector that you just drew. So put it wherever you feel like. Draw a point, label it D. So how would the distance from point D to point A compare to the distance from D to B? So think about how that distance from D to each of those 2 vertices would compare to each other. So since we know that D is on the perpendicular bisector, we know that the distance from D to A is the same as from D to B. We learned about that earlier in the year, so we know this to be true. And that's for any point that's on the perpendicular bisector, will be the same distance from either endpoint. So go ahead and take a look at this diagram, pause the video, and think about the 2 bullet points there, and then come back to the video and I will discuss it. So would point E be closer to A or closer to B? Or would it be equidistant? So we know that E will actually be equidistant. Let me move this up here. But since E is on the perpendicular bisector, we know it will be equidistant from those vertices. So since A and B are the vertices of that perpendicular bisector, then we know that E will be equidistant from those. So let me just move this down. So if we were talking about E to C versus B, that wouldn't be the case. But since A and B are the endpoints for that perpendicular bisector segment, then we know that E is equidistant from A and B. And then what about point F? And what about point G? So F, we know, would be closer to A because it's on the A side of the perpendicular bisector. So F is going to be, let me get this over here. So point F is going to be closer to A since it is on the A side of the perpendicular bisector. And then maybe I'll just get rid of this so I can put the typing in here. And then for point G, we know that point G will be closer to B because it is on the B side of the perpendicular bisector. So if it's on the perpendicular bisector, it is equidistant to the endpoints of the segment being bisected. If it's not on the bisector, okay, whichever side it's on, it will be closer to that vertex. All right, then on page, or for activity 2, we're actually going to use the perpendicular bisector, the same one that you just used on page 173. So now you're going to construct the perpendicular bisector of side BC. So go ahead and construct the perpendicular bisector of BC and then label the intersection point P. Then you're going to use a colored pencil to connect that point to each of the vertices and think about how they compare. Once you've gotten done with steps 1 and 2, then come back to the video. All right, so let's go ahead and I will construct the perpendicular bisector here quick for BC. So I'm just going to open this up to the width here, draw in a circle quick, move to this point, draw in the circle so I can get my perpendicular bisector. And then we're going to label the intersection of the perpendicular bisectors. So the perpendicular bisectors are my blue segments there. We are going to label the intersection point P. So right here, this will be point P. And then we want to connect P to each of the vertices. So pick whatever colored pencil color you would like, and you can just connect P to each of the vertices. So you're going to take and connect P to A, and then P to C, and then P to B. So what do we... how do they appear to compare? So how do those pink segments appear to compare? And so it kind of looks like they appear to be equal for the same size. And so what we're going to want to do here is then think about, okay, so they look like they're probably the same size. Now it wants us to think about if we were to do another perpendicular bisector. So now if you were to do the perpendicular bisector of AC, do you think it'll pass through P, and explain your reasoning? So I think it will, because it makes sense that any point, so any point on this, whoops, on the perpendicular bisector, let me get a new dot here. So any point on the perpendicular bisector, so any point on this blue bisector here will be equidistant from C as it is from B. So this point right here is the same distance from C as B. So we know these two pink lines are going to be the same. And if it's on this line right here, then it's going to be equidistant from A and B. So we know that these two segments are the same. And then if we make another perpendicular bisector, we know that this point would be the same distance from A as it is from C. Well, we already kind of talked about that all of those pink segments need to be equal. So this point would have to also be on the perpendicular bisector of AC. So go ahead and then actually construct that. I'm going to get rid of some of these circles so it doesn't look quite so distracting. But go ahead and construct the perpendicular bisector of AC. So again, you just have to open it up to more than halfway and then cross those. and get them connected and see if in fact it does go through P like we thought it would. And it does. Okay, so it is going through P right there, just like we thought, because now any point on this one's going to have to be equidistant from A as it is from C. And so all of those pink lines are going to be the same. So now they want us to construct a circle with P as the center. So go ahead and put your compass at P for the center, and then open it to the radius of A. So you want to go P to A, and then draw the circle around. So centered at P, open it up to A for the radius. Why does that circle also pass through B and C? Well, because PA is the same distance as PC is the same distance as PB. So these could all be radii of that circle that we just drew. So let me change its color and just change it to pink. But that circle has all of these segments as its radius. So it's going to pass through B and C because they're the same distance from P. So what kind of circle is that called that we just constructed around our triangle? Remember what that's called? So that's called a circumscribed circle, since it goes around the triangle and hits every vertex. So we saw some quadrilaterals that have circumscribed circles, but some don't. Do all triangles have a circumscribed circle, or only some? And the answer to that will be every triangle will. Okay, so all triangles. We'll be able to do the perpendicular bisectors of all three sides, get that circumcenter, and be able to draw that circumscribed circle. So you can write this on your reference chart. So the circumcenter, which is what we just constructed, is the point where all of the perpendicular bisectors meet. So we made all three perpendicular bisectors. That point that they meet at, that's the circumcenter. And we can use the circumcenter to draw the circumscribed circle. So if you just set your compass on the center and you open it to one of the vertices, you will end up being able to draw that circle around there. So the circumcenter is the point that's the same distance from each of these 3 points, because you could make a radii with each of those. All right, then on page 175, you can choose one of those 3 triangles to construct your perpendicular bisectors for, so that you can get the circumscribed circle. Okay, so go ahead, construct it. You'll do perpendicular bisectors, and remember, you only need to choose one. I'll put up the diagrams for each of them so that you can compare. Just construct the perpendicular bisectors of 1 so that you can get the circumcenter, which then will help you draw the circumscribed circle. So then try that. If you need help, come back to the video and I will construct it. All right, so I'm going to construct the perpendicular bisectors of each of these so that you can kind of see. And so when I construct perpendicular bisectors, I just open up my compass to wider than halfway on kind of the longest side, and I just draw in circles for each vertex. So I'm just going to open it to here. That's wider than halfway on all the sides. So I'm going to draw this one. I'm going to leave my compass the same size. I am going to change the color of the marker so that you can kind of see the difference here, but I'm not going to change the size of the compass setting. And then I will do it at the third vertex as well. All right, so then what this does, and let me just make these a little bit skinnier here. So then I'm able to just go ahead and connect where these are intersecting. And so I've got the purple and blue connecting here. So there's one purple, or there's one perpendicular bisector, and then I've got red and purple intersecting here. So I can connect that for another perpendicular bisector. And then I will make these dotted so they kind of disappear on the screen a little bit more. But there's the perpendicular bisectors. And so then this point where they intersect would be the circumcenter. So in order to draw the circumscribed circle, I would just set my compass as with that as the center, and then open up to any vertex. And then I could draw the circle, and it will hit the triangle at each vertex. So then you'll want to repeat that process for each of these different triangles. So I will just quickly do that here so that we can get them all on here, and then you can compare to yours. So there's my circles. I'm going to get the perpendicular bisectors drawn in now by connecting where these circles intersect. You only have to do 2 of them to get the circumcenter. Then remember, connect the circumcenter to one of the vertices to draw in your circumscribed circle. And then we'll get this last one here. All right. So then again, just connect the perpendicular bisectors there, and then that gets, that gets the circumcenter, and then that will help you draw in your circumscribed circle. That will hit each of the vertices. I think I'm a little bit off on this one because I didn't quite hit on the vertex, but we'll see. Yeah. So I was off a little bit on this one when I connected those perpendicular bisectors. But anyways, you can see kind of where the circumcenters were at for each of these. Let me just highlight them on here. So there's the circumcenter, there's the circumcenter, and then there's the circumcenter. So here's another drawing of each of those. And so if you kind of looked at where the circumcenters each were, okay, on your triangles. So we had a right triangle and it landed on the hypotenuse. This obtuse triangle, the circumcenter was outside. And this acute triangle, the circumcenter was inside. So why does it make sense that the right triangle's circumcenter would land on one of the sides? So why would that make sense? And if you look at this diagram up here, it's kind of trying to help you think about that, because if we think about that from the circumcenter, okay, so the circumcenter to each kind of edge here is going to be a radius. Okay, so each of these are radii, right, of this circle, if we kind of think about connecting. which means that this segment right here is actually a diameter. So it splits it into a 180-degree arc, which would make sense then, because then this angle here would be an inscribed angle from that 180-degree arc. So this would be 180 divided by 2 would give you 90, which forces that hypotenuse to be a diameter. So when you have a right triangle, it's always going to be on one of the sides. Okay, not one of the sides, but on the hypotenuse, because that's going to become the diameter. When you have an obtuse triangle, okay, this circumcenter is going to be outside of the triangle, because this is a bigger than 90-degree angle, so it's going to create a bigger than 180-degree arc. And then when you have an acute triangle, okay, all of these angles are less than 90, so they're going to be creating, so as inscribed angles, they're going to create arcs that are less than 180. So the circumcenter will be inside of the triangle. All right, so then if we think about in a desert, so we have scientists who want to build a supply hut the same distance from all 3 stations in the desert. So what should they do? So if we want a point that's equidistant from all of these, what we really want to construct is the circumcenter. So we want to think of this as a triangle. And if we constructed the circumcenter, then we would get the point that's equidistant from each of these. So we would just open up, okay, do the circles, get your circumcenter. And once you have your circumcenter, then you know that it's equidistant from all of those points. So let's see. All right, so then you can get your perpendicular bisectors created. And then this point right here would be the point that is equidistant from each of those stations, since it is going to be the center of the circle that could be drawn around them. So then each of these lengths right here, let me figure out a color that'll work. From this center point to each station, each of these are going to be the exact same length, since they're going to be the radius of that circle. So if you want a point that's the same distance from 3 points, you would want to construct the circumcenter. All right, so the lesson synthesis, all triangles will have circumscribed circles. So we'll be able to construct perpendicular bisectors of all 3 sides. Really, you only have to do 2 to get the intersection. The third one will definitely go through there. And then that circumcenter is going to create that circumscribed circle around there. So then the circumcenter to each vertex will be a radius. So D to A, D to B, and D to C will be a radius. So they're all going to be the same length. So all those green lines are the same length. Also remember that the circumcenter for an acute triangle is located inside the triangle. For an obtuse triangle, it's going to be outside of the triangle. And for a right triangle, it's going to be on the triangle. So we're looking at this being the triangle, right? And then the circumcenter is inside of it. So that circumcenter is outside when it's obtuse, and then it's on the hypotenuse when it's a right triangle. And then you can go ahead and try this cool down. If you're struggling with it, be sure that you reach out to your teacher to ask for help.